Collect the definitions and simple properties of examples of stochastic process. First, the Poisson process. The probability masses of Poisson process is this: xt equals to e powers minus lambda t, and multiply the lambda t powers n over n fractions. It's the same as very similar to the Poisson distribution. Just replace the lambda to lambda t, and here is the mean of Poisson stochastic process is equals to lambda t, and the autocorrelation is equals to lambda multiplied the minimum of T1 and T2, and this process is used to model random points in time and space. Second one is Poisson increments. Poisson increments yt can equals to xt plus c minus xt over c, and the xt is the Poisson process, so the probability of yt equals to n over c will same as the Poisson process, but the t will replace to the c, which means the interval of time, and the mean of Poisson increments is equals to lambda. And when t and t2 is disjointly, and the autocorrelation is equals to lambda square. If they are jointly, then it's equals to lambda square plus lambda square over c minus lambda multiplied t2 minus t1 over c square. And it is used to model random points during time c. So the last one is normal process. The normal process is based on the notion of the Gaussian distribution. So Gaussian process can be seen as an infinite dimensional generalization of multivariate normal distribution. Here we use the t to represent the infinite dimensional. So the normal process xt mean is mu t, and is correlation is this. Second question also is collect the definitions of properties of stochastic process. First is wide sense stationary process. In WWS, the process mean is a constant, is independent to t, and the correlated is function of t2 minus t1. Second one, independent increment process. For example, we have this t1 smaller than t2 smaller than t3 smaller than t4. The intervals of t2 minus t1 and t4 minus t3 does not have intersection. Then if the PDF of xt2 minus t1 and xt4 minus t3, if the PDF of process xt is independent, the stochastic process xt is independent increment process. The third is Markov process. Markov process satisfies the Markov properties if one can make predictions from the future of the process. Based on that, based solely on its present state, just as well one could know in the process full history. In mathematical equation, we can have this. The probability at time t1, the xt1 minus smaller than x1, in the condition of xt2 to xtn small equals the xt2 xt3, where equals to in the condition of xt2 equals x2, which means we don't need know the situation before the xt2. We just need the situation, the time before xt1. The fourth one is strict stationary process. In mathematics, is the CDF fx, the CDF fx1 to xn, t1 to tn will equals to x1 to xn, t1 plus c to tn plus c. The fifth one is white noise. White noise NT1 and NT2 are uncorrelated. So the mean of so the correlation of NT is the mean of NT1 minus the mean of T1 and multiply the NT2 minus the mean of T2, and it will equals to the correlated T1 T2 minus the mean of T1 multiply the mean of T2, which equals to the QT1 multiply delta T1 minus T2.